Welcome back to Designing AI-driven Personalized Learning Environments course. In this video, we will talk about example of fraction addition using rule-based model in the domain model. So, before we start, I would like to reflect on this question. What are the steps to solve fraction addition? Consider the fraction addition of 3 by 4 plus 2 by 6. What are the steps involved in doing fractionation? Please pause the video, write down the steps involved in the fraction addition, then play the video. The first will be, if you want to solve the fraction addition, for example 3 by 4 into 9 by 8. So, if you want to solve this particular problem, the first step will be check whether the denominators are equal. Of course, it is not equal, 4 and 8 are not equal. So, we need to make sure how to make the denominators equal. So, identify number types, these are not same denominator. Then if it is not, we should make the denominator same. To do that, we should do the least common multiplier. Here it is a 8, so that 4 can be multiplied with 2, so that you could make the denominator. So, we should know what to identify the least common multiplier. This is a sub-concept, a prior request concept required for this particular addition. Then multiply the numerator and denominator for the same multiplier. That is, if you are multiplying into 2 to convert 4 into 8, you should have the same multiplier for the numerator also. So, 3 will multiply by 2, that is 6, 4 multiplied by 2, 3, 8. So, 6 by 8 plus 9 by 8 would come. This step will be 3 into 2, 4 into 2 plus, here the multiplier is only 1. So, that is the multiplication problem. So, after this will be 6 by 8 plus 9 by 8. Okay. So, this is the least common multiplier. Do it. Now, since both are same, keep the denominator, both are function, just add the numerators. That will be like 8 and 6 plus 9, 15. Okay. That is the some results of this this particular question. If possible, if you can reduce the fraction to simple form, please reduce it. In this particular case, you cannot do it, so don't do that. So, if you can reduce it, do it. So, these are the steps. I think you would have thought about all the steps when you paused the video. These are very basic steps in the fraction addition, right? So, can we convert these into rules? Let's think. So, the fraction addition problem in this 3 by 4 and 9 by 8, fraction should have a common should have a common denominator. So, to do that, you have to do LCM. The simple LCM is take the 8 and do the multiples of 8 and see wherever the 4 can be divided. 8, 16, 24, 32, 40. The 4 can be part of anywhere. So, instead 8 is the least common multiplier. Let us take the 8 and convert both into a 8, convert both for the equal denominator, then add the numerator. The denominator will be added like a 6 plus 9, 5. Suppose you are taking the even better, not instead of LCM, if you are taking the bigger multiplier of 8, that is a 32, if you convert it will get a 60 by 32, but you could simplify the fractions, you will end up with 15 by 8. So, the idea is that you should be able to LCM. If you do LCM, it will be only 8 will come, but even if you are doing the the higher denominator, you can able to simplify it. So, the goal is that there is a set of sub goals. Sub goals is that check whether they are equal denominator. If not, you have to convert both denominator to be same, then add the numerators, then simplify it. So, 3 steps basically. Then this particular 3 goals should follow in the order. I cannot do the add numerator, then I will convert the denominator. That is not possible. Instead, you have to first convert the denominator to make it equal, then add it, then simplify it. This is the order. So, the sub goals order steps is not enforced, but within the whole overall goal, sub goal step is enforced. Let us see in example in detail. This is how the rule based model is created. For example, in a fraction, the first step is that numerator denominator into converter form. This is the numerator, say 3 by, suppose the given value is 3 by 4 and 9 by 8. This is the given form. You know these two numbers. Now you have to convert the fraction and numerator into a new form. That is, the goal is that you have to get the fraction value. Second is denominator value, and denominator done, numerator done, all done. Which means the first step is the denominator value. I need to find out the denominator value is being converted or not. After converting the fraction, this goal, then I have to say I have done denominator conversion. So these two steps are given fraction. Converted fractions here, I need to take the value, find the common denominator, and I have to convert it. Here the conversion happens in this step. In this step the conversion happens such that there will be like 6 by 8. This is a one fraction. The second fraction will be 9 by 8. This is the second step you are doing. The third step, answer fractions. In the answer fractions, you just add the fractions, and if you want to simplify, simplify it and give the final value. This is the idea. So there are 4 steps, right? This answer is 1 by 4 by 1 by 6 is given, 1, 4, 1 by 4, and 1 by 6 is given. This should be 1 by plus 1 by 6 for this particular thing. Then you are converted and give it. There are 4 steps. One is given fractions, convert the fractions, answer the fractions. Then set of sub goals. The sub goals are convert fraction goal, add fractions, and reduce fractions. There are 3 sub goals in this problem, these sub goals, and after it's done. So there are 3 sub goals. The order of 3 sub goals is strictly maintained, but within the sub goal, that is the 3 things, is not maintained. So each fact or chunk constrains attributes or the slots, which can be the another fact or the values. This is the each chunk, and also you should have the sub goals, and that order should be followed. So 2 things very important. One is sub goals, that is chunk, the chunks of the whole problem. Order of sub goals. The order is mentioned in this particular thing. This is sub goals. That order is basically first do conversion, do the fraction, third reduce the fraction. These 2 orders are strictly maintained, that's all. So this particular problem, we need to have a table saying that this is a given fraction, 2 values, converted fraction, there's a space, answer fraction there should be a space, and sub goals has to be stored in the back end, and you have to check it. That's the idea. So you see the simple fraction addition, we have to spend some time on creating the rules so that system can work for any given problem. This particular rule will set and work. So to convert it, we'll just go into rules as such, if and then rules based on the production rules. The sub goals are generated by the rules while solving the fraction. Okay, and when the fraction question comes up, sub goals already have been created. It will be generated, quickly shown to you, because the values will change. If there is no sub goals, okay, because we are starting as a very first sub goals, and the d1 is a denominator first given fraction, d2 is the second given fraction, then LCD least common denominator to the least common denominator, d1 and d2. Add sub goals to convert the fractions to denominator LCD. Add the sub goal to add 2 converted fractions. So you have to add three sub goals. One is converting, finding the common denominator. Then sub goals to convert fractions to the goal and adding the converted fractions. This is the first sub goal. Okay. Now the model does not care how do you determine the multiples of the function. That is not a goal, because that is a prior required concept, and that particular concept you might have already done. That is assumption. After converting, if the sub goal is to convert a fraction f, so the denominator is d, then denominator for converted fraction has not been entered, then write d as a denominator for converted fractions and make note that denominator has been taken care. So if this rule, if there is a sub goal to convert a fraction f, that is in the previous slide, there is a sub goal, you are adding sub goal of convert the fractions. So now this particular sub goal comes into picture. Initially you start with there is no sub goal, after this particular step you are adding the new sub goals. Okay. Now the sub goal is exist, then if the denominator is d, add the denominator for the converted fraction has to be entered yet. If there is no, you are converted but you are not entered the value, enter the d value as a denominator fraction and make note that this particular sub goal is done. Then go to the second sub goal. If the sub goal of converted fraction, the denominator is c, then you have to do the same, same function. That numerator for converted fraction has been not been entered, then add a original numerator f, then add original denominator to the denominator because df is the fraction, right? Numerator is equal to numerator into d by denominator as numerator converted fraction, and make note that numerator has been taken care. Suppose you are converting the value of denominator into particular multiplier, the same multiplier should be done with the numerator also, so the numerator is taken care. The second sub goal within the convert fraction is done. Using that we could actually solve any given fraction rules within this production rule. The production rule simply says that if the given problem is this, then the action should be converting. If the given problem is converting actions, action should be make sure that the numerator denominator are properly multiplied. If the action is simply adding, make sure that the numerator is added. These are the conversion production rules in the fraction addition. So I think you don't need to go detail into writing these many rules. Instead, think given a problem, what are the sub goals and what is the order of sub goals. That is what I wanted you to think in this particular thing. I wanted to show how this one simple fraction addition has been, production rule has been created so that it can work for any fraction addition problems in the cognitive tutor. That is the tutor they use. Now I want you to take a reflection on this question. Consider a fraction addition problem 1 by 6 plus 3 by 8. Suppose the rules are implemented, that the productions are implemented, and the student answers the denominator as a 14. Okay, what will give the feedback? Just pause this video for a minute and read all the options and think about it and note down what is your feedback, then play the video. So in this particular question, I think the buggy rule will catch such that the student simply added the denominator 6 plus 8 is equal to 14. The student did not know converting the fractions to a common LCM, the common denominator. So what are the rules come? So there's a buggy rule. Definitely if you are creating the fraction addition problem, you would have definitely thought about the common misconception is that student would be adding the denominator without doing the common multiplier or without finding the common denominator. So this buggy rule can go. The first thing is you mark it as incorrect. Then you should say that it looks like you added a denominator directly. Then you can also recommend you can find a common multiple. So this particular answer except mark correct, all the three options are correct. Now it is up to you what kind of feedback to give. As a system expert, you would mark incorrect finally because you showed that this particular answer entered 14 is not correct in the particular step. Then you could say that hey, you should add it. Then you should find a common multiple. That is the idea. So consider the student enters 24 as the denominator for the second fraction. The tutor can mark it correct. The enters 14 as the denominator, it looks like you are adding denominator, but you need to have common multiple. It marks incorrect. The student enters 9 as the denominator, this marks correct because it is not within the correct rule or the buggy rule. So it can be anything. So can be no message because student can be thinking something else. You can't actually give any feedback. Instead, you say it is wrong. Try again. That's all we can say. So is it clear? There can be one production rule which is matching with the exact expected answer. Another set of production rules which is trying to capture all the buggy rules. The third set of rules where it is not matching both, you say no messages or the try again. So we'll do the second problem here. So in this domain model of geometry tutor, it's the same cognitive tutor, but they have created for geometrical problems. These two sides are equal, side BC and side AC is equal. The angle Angle A is 65, this is 65. What is the angle of C? So how do you identify? So you have to go. The production rule is very simple. If the goal is to find an angle in an isosceles triangle, because the two sides are equal, this is isosceles triangle, and AC is equal to BC, it can be anything. AC, in this particular sum it's AC, and one of the angle is shown, then set the angle of value B equal to same as A. In the simple rule is, in an isosceles triangle, which is the triangle which is both sides are equal, if angle AC and BC are same, for example this AC and BC are same, if the angle A is given as a 65, okay, known, then set angle B is equal to angle A. This is the action. Okay, this is very first basic rule. Then if I want to find the angle C, what you should do, you should apply the triangle rule. If the three angles are there, if you know the rules, angle of A and B already known, then C is equal to 180 minus A plus A minus B, you know. So because angle A plus angle B plus angle C will be 180 degree. So you should actually find angle C by subtracting angle A and angle B from the 180. So these are the rules. We need to come up with the two rules. The rules are simple. The rules are, first make sure the triangle is isosceles and the two sides are equal. If one of the side angle is known, other side angle can be substituted. Second rule, in a triangle, if you know the two angles, you should compute the other angle by subtracting two angles from the 180, the sum of the angles. So in this particular tutor, there are only two rules. The order is also fixed. Order is first assign the unknown angle of B to the A, then find the angle C. This order has to maintain. This is a set of rules. Now you don't need to worry about the previous production rules with fraction. Even if you are able to write rules in this particular format, this is enough for the cognitive tutor. Okay, and we'll see one more example. In this example, this is how the cognitive tutor actually looks like. I just want to show the cognitive tutor looks in the one of the system. They have a lot of skills, 32, 42. These are the some of the skills. Consider the skill is changing. This is the diagram is given to you, and you have to enter this. This is given. This is given. You have to enter this value. Okay. So given is in this particular problem, the 47.7 degree in EWD, this particular angle is 47.3 and angle WDE is 58 degree. Angle WDE is 58 degree, and find the unknown measurements. Now this first step will be, I need to identify, the first rule will be, the theorem says that sum of measure of three interior angle of triangle equal to 180 degree. The first, this is the reading material if the student wants to read more and glossary want to do. The first rule is, in any triangle in this problem, the angle, that is the sum of this angle is, sum of the triangle angles are equal to 180 degree. So you have to do, to find this angle, you have to do 180 minus 47.3 minus 58. So that is the answer. So that will be the triangle sum rule you have to apply, and you have to find this. This you have to enter. Even these two you have to enter, but it is given to you. You have to say given rule. Now you know there is a 74.7 this angle. What is this angle? The next rule would come in a straight line. Sum of the angles will be 180. So 180 minus 74.3. The rule you have to enter. If you want a hint, you can click the hint. Then you could say you get the next hint and you get the idea. So based on these, a student's responses, we could provide a right kind of hint. A student entered any misconception or any buggy answers, we could go give the proper, remedial content, proper hint, so the student can understand how the sum of the three angles, is equal to 180 degree. I can show the glossary, I show the learning content to do that. This is how the system works. I hope how the rule based model is working, how they created a domain content. This is how domain content looks like, with content with rules and with step the process and what hints to provide, all those details are given in the rule based system. In fact, this also acts as a pet logic a bit because it decides which hint to provide, but rule based model is one of the very good example for how to write a proper domain model in your system. This has been used from from early 2000s to now, but it is very famous and it has been used for many systems, not only the math systems, maths, cognitive tutor. The same concept of cognitive tutor authoring tool has been used to replicate in the multiple domains, multiple topics across the world. So I want you to see 3 different problems. I want you to take it as a small homework. Think of any simple math problem and develop a rule-based system. I wanted you to come up with the sub-goals. I want you to create the production rules for the problem you are given. So take your time, pause the video and write up your own production rules and think of this as one of the homework for this particular video. Thank you.